Okay, so here's the first comparison test, and I'll give you a couple of minutes to write this, and then we'll kind of think about what this is saying. All right, so for this comparison test, you need two series. Well, the problem that you're trying to figure out is going to be one of them. And the other one is something you're going to have to pull out of your toolbox of series, of things that we can use to determine if a series converges or diverges. And so what this comparison test is saying is this. Suppose we want to find out if series A sub n converges or diverges. And then we have another series that we know what happens. So we have a second series, series B sub n, that we know what happens with B sub n. And then I want to compare the sequence part, compare term for term the sequence part. We compare the sequences A sub n and B sub n. And if series B sub n converges and term for term on the sequence A sub n is smaller than B sub n, then series A sub n will also converge. That's what this is saying. So compare the sequences, and if we know this, if series B sub n converges and the first term of A sub n is less than or equal to the first term of B sub n. The second term of A sub n is less than or equal to the second term of B sub n. And the third term of A sub n is less than or equal to the third term of B sub n. Then we know this. Then series A sub n also converges.
Now this doesn't tell us what it converges to.
It does not tell us what it converges to.
Does it tell us if it converges to a number that's less than B sub n converges to?
No, it doesn't tell you that either. We just would know that they would both converge. And on the flip side, if, this is the part 2, if series B sub n diverges and the term for term, the first term of A sub 1 is greater than or equal to the first term of B sub 1. A sub 1 is greater than or equal to B sub 1. A sub 2 is greater than or equal to B sub 2. A sub 3 is greater than or equal to B sub 3. So if you have that, and it says for all n, but then we would know series A sub n also diverges. Really, it says for all n, but you could say if after some point, you know, maybe A sub 7 is smaller than B sub 7. Maybe A sub 8 is smaller than B sub 8. But maybe when n is 10 and higher, this inequality, A sub 10 is greater than or equal to B sub 10. A sub 11 is greater than or equal to B sub 11. And if we know series B sub n diverges, then series A sub n diverges. So, well, it says for all n, n, because at some point this inequality holds, and it's going to hold for every value of n after that, then you could also use the comparison test. Now, what would you pick for b sub n? Here's one of your best friends, the p series. Think about the p series. The sum of 1 over n to the p. This was from yesterday's class. What about this series? When does it diverge? When does it converge? Here, think about the p series for series b sub n. P series converges when what? P's
Less than 1.
greater than 1. And P series diverges, there it is, when P is less than or equal to 1. So that's a big player in the comparison test.